is dealing with mid-segments of triangles. And I feel like this one, the concept is not hard, but it easily gets flipped the wrong way, okay? So just make sure as we go through that you know which one is which. You'll see what I mean in just a minute. But this picture right here, let's get a pen. So this picture shows you mid-segments in a triangle. So, excuse me, it's a segment that joins the midpoints of two sides of a triangle. So like here's a midpoint A, right? These two pieces are congruent, so that's a midpoint. Now go to the other side, XZ. B is a midpoint, right? These two pieces are congruent, so we know B is right in the middle of that segment. When you find the 2 points that are the midpoints and you connect them, you end up with what's called a mid-segment, okay? So AB is a mid-segment. Can you tell me another mid-segment? What? BC is a mid-segment. And there's one more. AC is a mid-segment, right? These are congruent, these are congruent. So we know we have a midpoint there. So AC would be our third mid-segment, okay? With mid-segments, there's two properties that go along with this. It's actually the theorem right here. Right here. The triangle mid-segment theorem gives you these two properties, okay? The first says it is always parallel to the third side of the triangle. So if you look at our picture up here, what it's saying is our mid-segment AB, for instance, okay, so mid-segment AB will be parallel to the side across from it. So we would say AB is parallel to YZ, okay? So what is BC parallel to? BC would be parallel to XY. Okay, and then the third one, AC, is parallel to what? To XZ, right, to this side here. Okay, so that's the first property. You will have parallel sides with the mid-segment and the side across from it, okay? And then the other one, and this is the one you do more with, its length is half the length of the third side. So we just found which ones are related to each other, right? Red with red, blue with blue, green with green. Their lengths will always be half, the shorter one is always half the length of the longer one, okay? So if we were gonna write that here, we would say that AB, if I'm sticking with colors, is half of segment YZ. Okay, so if I knew the length of YZ and I cut it in half, I would get the length of AB. Okay, that also means that BC is half the length of, where'd I go? BC XY. Okay, and that means that AC is half the length of XZ. Okay, so really I'm just saying the same thing with three different sets of lines here. Do you see that? My color coding hopefully shows you that. If they ever talk about a mid-segment triangle, they're just talking about this triangle here. The triangle that is the mid-segments all joined is the mid-segment triangle. Okay, so the triangle mid-segment theorem, like I said, uses those two properties. It says in a triangle, the segment joining the midpoints of any two sides will be parallel to the third and half its length, okay? This is where people usually make the mistakes, and not because you didn't know what you were doing, just because you didn't stop and think about what you were doing, because you'll see why this makes sense this way. So this first problem, it says, given that JK has a length of 10, so this here, JK, has a length of 10, DE is 6.5. I'm going to zoom in a little here. So this length here is 6.5, And then the third length, EL, is 3.7. Okay, and that's just representing this length here. Okay, so let's think about what the mid-segment theorem says. And I'm not even gonna fill these in right now piece by piece. We're gonna fill in everything we know. And if you wanna fill them into those specific segments, you can. Maybe I will in a minute. But right now, I just wanna see what do you know in this problem. So, for instance, this KD here, can you tell me how long that is? It's 5. If we know these are congruent and the whole length is 10, that's got to be 5 and 5. Okay? Now think about this one for me. We know this whole side is 10. Do you know EF? EF would be the mid-segment. So it's got to be half of that length. That whole length over here is 10, so you're doing half of 10, or 5. Okay, so this length here is 5. All right, now let's look at DE. DE is 6.5. Can you tell me the length of KL then? If the 6.5 is the mid-segment, 13, right? That has to be twice as much because the mid-segment is half as much. So I can take this length and double it, and that will be the whole thing. So KL would be 2 times 6.5, and that's 13. Okay, now notice this. One of them I multiplied by a half, one of them I multiplied by 2. It's because one of them I was given the mid-segment and one of them I was given the side across from it. You have to pay attention to that because a lot of times people will see this and they'll go, oh, this is 6.5. Well, that's got to be, the other side has to be half as long, which doesn't make any sense, right? It does not make sense that this side here is half the length of 6.5. You would never say this looks like 3.25. It's obviously longer, right? So this is where I just need you to be reasonable, logical thinkers. Don't give me an answer without thinking, does it make sense? Because that's usually the mistake I see made on these problems, okay? Okay, finish this up. JE, what is that? 3.7, right? These are marked congruent, so that's gonna be 3.7. So what is this side right here, DF? 3.7, okay? If you look at it, 3.7 and 7.4, one is half the other, okay? So if you want to go through and fill these all in, let's see. KD would be 5, DJ would be 5, DF is 3.7, JL is 7.4, KF is 6.5, and FL would be 6.5 also. Okay. Any questions on that setup? Okay, then let's look at kind of the format you're going to see a lot of these in. Problem number 2 here. Okay, if I'm given a triangle, what is this called? The 54? That's the mid-segment, right? It's a segment where it's the midpoint connected to the midpoint of another side, okay? So that's a mid-segment. What do you know about a mid-segment?
It's in the middle.
It's half the side across from it, okay? And here's where a lot of people will make the mistake because a lot of people will say 54 equals half of 3n. No, I said that the right way. A lot of people will say 3n equals half of 54, okay? That's not true. You can either think of it as if I were to double 54, it would be the same as 3n. So I could say 3n equals 2 of the 54s. Or if you want to set it up the way the theorem says it, you would say 54 is half of 3n. Okay, now that's going to get you a decimal, 1.5. And then you would divide by 1.5. I always with those just prefer to avoid the decimals, so I would set it up this way, but it's not wrong either way. What is wrong is if you say 3n equals half of 54, because when you do that, you would get that n is 9, which would make this whole side 27. Does it make sense for this to be 27 and this piece to be 54? No, okay? Be reasonable, logical thinkers. This does not work, okay? Either one of those other two will work. So if we do that, if we solve this, so I would take 3n equals 108 and divide by 3. So what is n? 3 goes into 108 36 times. So n should be 36. Now, if you're not sure when you get an answer, what could you do? Plug it in, okay? Just substitute it for your n. So if I plug this in here, 3 times 36 is 108. 54 is half of 108, okay? All right, so look at this second one. How could you set this up? There's 2 ways you could write it, a couple ways you couldn't write it. What's one way that you could write it? Okay, so if you're gonna double this one, just make sure you do parentheses because you need to distribute it to both those parts. So 2 times n minus 1 equals 46, that's one option. What's the other way you could write it? N minus 9 equals what? Half of 46, right? So 1/2 of 46. Again, either one of these is correct. What is not correct is if you say half of n minus 9 equals 46, okay? So if you solve this, n minus 9 equals 23, and then you add 9, so you get n equals 32. Questions on that? Okay, so what if we get a little fancier in the way it's drawn? We have this, and it says, in the house's roof, as shown below, find the height x of the support. So if you're going to build a roof, this is very applicable. Do you see a triangle mid-segment setup that will help you find x? What would x be? Right. So you can set it up. This would be the mid-segment of this triangle, right? So that means x and 3 are parallel, and they are also, x is also half of the 3 feet. So you could say x equals half of your 3 feet. So x would equal 1.5 feet. Okay, what does that mean for this piece? It's the same thing, right? Another triangle, another mid-segment. Questions? Okay, you do number 1 here. Work that out, see what you get. Do you have an answer? What'd you get? 13. Okay, so 2 ways you could set this up. Tell me one of the ways you set it up. Two times 5. Okay, yeah, so you could double the 5 and set that equal to 2n minus 16. What's the other way you could set it up? Right, so 5 would equal half of 2n minus 16. So either one of those ways is correct. You get 10 equals 2n minus 16, so add the 16, so 26 equals 2n, and then divide by 2, so n would be 13. Okay, and again, if you're not sure, plug it in, see if it makes sense. That should come out to 10, right? It should be double the mid-segment. Number 2, I would do it this way. I would do 4n plus 3 equals half of 86. Don't have to. You could double the 4n plus 3, but this would be 4n plus 3 equals 43. Take away the 3. So 4n equals 40, and divide by 4. So n would be 10. Okay? Questions on those thus far? Okay, there's a couple more there. If you want to give those a shot on your own, go for it. I'm going to show you one other type of problem, and maybe this problem itself is not super applicable for you, but the concept behind it can be super applicable if you ever need to measure something and you don't have a way to measure it, okay? So here's what we're going to do for our last problem here. This is example 4. You're on the swim team, and your swim coach says, if you're going on vacation, you better do some laps to make sure you get in, 3 miles a day. I want you to swim 3 miles a day. And you go to a lake, but you have no idea how far it is across that lake. Here's what you could do to measure how far this distance is. Okay, if we're trying to figure out what is this, so we know how far you need to swim, or how many times across to get the mileage in that you need, what you could do is if you start here, okay, and I walk this way until I can go perfectly across here without hitting any part of the lake, okay? I could put a post in the ground and just measure how many paces I did. So let's say we walked this and it was 35 paces. Okay, well, if I keep going the same direction then, another 35 paces, and put something in the ground there, I just created a midpoint of that segment. Okay, where do you think we'd go next? The other side, right? I'm gonna walk this distance to the other point here. Why can't I stop in the middle right now? We don't know how far it is, so we don't know where the middle is, right? But if I walk this whole distance and I find that it's 236 paces, then where can I go to find my midpoint? I'm here right now. Where do I need to be? Right here, right? So if I walk back half of this distance, so 118 paces, that gets me a midpoint here. You should be able to tell me with one more step how far it is across the lake. Do you see it? Not 118 plus 35. I'm here. Where can I go to figure out how far it is across the lake? Walk the mid-segment, right? If I walk here and I find that that is 128 paces, then what is the number of paces across the lake? Because you can't walk across the lake. You're not Jesus, right? It'd be awesome, but 256. So if it's 256 paces across the lake and we figure a pace is about 3 feet, okay, you would just go 256 times 3 would tell you how many feet it is across the lake, which would be 768 feet, okay? So again, maybe it's not a lake in your world, but if you need to know how far it is from point A to point B and you can't just walk it off because there's some obstruction in the way, you can always do this. Make a mid-segment by going there and back, oops. And then you just have to walk this piece off and you'll know that piece. Isn't that beautiful? It's so good. I hope you all use that someday. Any questions on that? Okay.